Greeting and welcome to our presentation on the application of differentiations. Before jumping into the video, allow me to introduce the members of Group F. The group members are Muhamad Salihin bin Lamjin, Kimberly Mac Uson anak Michael, and me myself Nurul Farhana Binti Daip. We are from class CS1102R. Without wasting any more time, let's get right into the video presentation.
Welcome! In this video, we will be looking into related rates. Before starting, let's look at the overview of today's topic. Number 1, what is related rates? Number 2, why is related rates important? And number 3, we will see some of the example of related rates problem and how do we solve it. So, what exactly is related rates? We can say that related rates are usually problems that involve two or more variables that change at the same time, possibly at different rates. Why is it important then, you might ask? Well, if we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing as well. This usually involves writing an equation relating the two variables and taking the derivative of the equation with respect to time. Implicit differentiation is also often used when trying to solve related rates problems. To understand related rates better, just imagine a balloon is being inflated. When air is pumped into the balloon, we can see that the radius and the volume of the balloon are also increasing. Thus, we can say these rates are related.
Now that you know what is related rates, let me show you an example on how to calculate a related rate question. So in this question, it says that Aidil is working as a part-timer at Disneyland. Every day he would inflate balloons and give it to the visitors. Find the rate of change of the surface area if Aidil inflates a balloon at the rate of 10 centimeters cubed per second. The radius of the balloon is 8 centimeters. Now from this question, we know that the dV over dt is 10 centimeter cubed per second and the radius is 8 centimeters. The question is asking us to find the rate of change of the surface area of a balloon. So to find the dA over dt, we need to equals it to dA over dV times with dV over dt. But since we cannot really find the dA over dV, we need to split them, so it will become dA over dr times with dr over dv times with dv over dt. To find the dA over dr, we first need to find the surface area of the sphere. Now the formula of a surface area of a sphere is 4 pi r squared. Now to find the dA over dr, we need to split 4 pi with r squared. And then we need to differentiate the r square, so it will become 2r. Now we need to times the 4 pi with 2r, so it will become 8 pi r. Next is to find the dr over dv. To find dr over dv, we first need to find the volume of the sphere. So the volume of a sphere is 4 over 3 pi r cubed. Now to find the dV over dr, we need to separate 4 over 3 pi with r cubed. Now when we differentiate r cubed, it will become 3r squared. Now the 3r squared we will multiply with 4 over 3 pi. Then it will become 4 pi r squared. Now for us to find the dr over dv, it will become 1 over 4 pi r squared. Now that we know what is dA over dr and dr over dv, We can now find dA over dt. So to find dA over dt, we just need to multiply 8 pi r with 1 over 4 pi r squared with 10. So if we multiply 8 pi r with 1 over 4 pi r squared, it will become 8 pi r over 4 pi r squared multiplies with 10. Now when we multiply it together, it will become 20 over r. Now that we know that the dA over dt is equals to 20 over r, we need to replace the r with our radius given, which is 8 cm. So 20 over 8 is equals to 2.5 cm square per second. Now we can conclude that the rate of change of the surface area of the inflated balloon is equals to 2.5 cm square per second.
From the problem statement, without we realizing it or not, the application of differentiation has been used generally throughout our daily lives. Keep in mind that it is not limited to solve these kinds of problems, but real-world problems can also be used to the concept of differentiation, although they can be subject to multiple factors and will be required to be more in-depth analysis towards their surrounding. Therefore, we must understand the concept of differentiation as it can be used and help us in solving the real-world problem that we face in our daily lives. That's all from our presentation. We hope you enjoyed watching our presentation video. Thank you, stay safe, take care, and have a nice day.